Hello friends, welcome to Hera for Mathematics, the center of excellence in mathematics, the center where you can always learn the basis of mathematics. Today I have a very beautiful question for you on a trigonometric identity. Prove that sin square theta plus cos square theta is equal to 1. Looking at this, you know that this is a trigonometric identity, one of the trigonometric identities. So the very first thing to do is just to draw a right angle triangle. So let's draw that. This is a right angle triangle. The right angle triangle is always having one of the interior angle of the triangle to be equal to 90 degrees. So let's assume this is our 90 degree, and let's assume this is our theta. So the angle that is the side that is facing the angle is being represented by here is the opposite. The longest side, let it be C, while the other side, which is the adjacent, be B. So with this, let's use our Pythagoras theorem. Our Pythagoras theorem states that the square of the hypotenuse is always equal to the square of the opposite plus the square of the adjacent. So let's do that. So we have our C square to be equals to A square plus B square. So that is Pythagoras theorem. So it's a basis. Now with this, you now go back to this triangle. You now find sin theta first. What is our sin theta? We have our sin theta to be equals to opposite, which is A, over hypotenuse, which is C. But we want sin square theta. We want sin square theta. So with this, you can always say, from this we have sin square theta to be equals to A all over C. Then you square. So no magic in that. So how to square this now? You now know that you can always split it in indices. You have our A square all over C square. You know, this is our equation 1. This is our equation 2. So from this now, let's just try to find cos theta and see what happens. So we have our cos theta to be equals to adjacent, which is B, all over C. Therefore, our cos square theta, which we really want, will be equals to B square, B all over C, all squared. Then you share it of indices. We have our B square all over C square, which is our equation 3. So with this now, we've calculated the value of sin square theta to be this. We've calculated the value of cos square theta to be this. So why don't we just add it together like we've added here and see what happens. So with this now, you now have a sin square theta plus cos square theta. Sin square theta plus cos square theta will now be equals to what? Will now be A square all over C square plus B square all over C square. So we'll now change it to fractional. So with this, you just try to find the LCM of this, which is going to be C square. C square goes to C square only one time. You use that one to multiply A square, you have A square in return. Plus, so C square goes to C square only once. You use 1 to multiply B square, you have this B square. So from this, our A square plus B square is C square here from 1. So we now have C square equal all over C square equals to, so C square goes to C square 1, 1, which is equals to 1. So this will say that sin square theta plus cos square theta is equal to this. Then A square plus B square over C square. Now C square over C square. Be mindful of the fact that this A square from this guy is being drawn from the first equation. So you now have 1 in return. Thank you very much. I'm Rafis, my name popularly known as Ogolas of Prep Writer Worldwide. You can always watch my mathematics videos on Online Mathematics on Facebook. Subscribe to my YouTube channel. You can always enjoy my mathematics videos. Thank you. God bless. Kasha.